Hey everyone, and welcome to today's Explainer. I am so excited because today I'm putting on my teacher hat and we are going on a geometry puzzle-solving adventure. Seriously, if you've ever wondered how architects design those epic, towering skyscrapers, or how game developers build the incredible 3D worlds you play in every day, well, it all comes down to a secret language, and that language is geometry. So today, we're going to master the geometry puzzle by unlocking the secrets of angles and transversals. Let's get into it. Here are the 6 levels we're going to beat today. The building blocks of angles, meet the basic angles, dynamic duos, crossing the parallel universe, the Z, F, and C rules, and finally, solving the geometry puzzle. All right, level 1, the building blocks of angles. Before we can solve the really complex puzzles, we've got to understand our very first puzzle piece. Imagine drawing 2 completely straight lines on a piece of paper. What happens at the exact spot where those 2 lines crash into each other? I want you to just think about this for a second. What exactly is an angle? We use the word all the time, right? You might angle your camera to get a better selfie, or angle your body to block a soccer ball. But in math, what are we actually talking about here? Well, here's our mathematical definition. An angle is really all about measuring the amount of a turn or rotation. When 2 straight lines, or rays, meet at a common endpoint, which we call a vertex, they form an angle. And we measure that amount of turn in something called degrees. You know, you've probably seen tools like a set square or maybe a half-circle tool called a protractor lying around your classroom. We use these physical tools to measure those exact degrees of rotation so we can build things perfectly in the real world. Okay, level 2, meet the basic angles. Awesome job beating the first level. Now it's time to meet the cast of characters in our game. First up is the acute angle. I always like to think of it as a small, cute angle. It represents a very tight turn. An acute angle is always greater than 0 degrees, but it is strictly less than 90 degrees. It's super sharp, kind of like the tip of a pizza slice. Next, we open that, turn up just a bit more to meet the right angle. This one is exactly 90 degrees, no more, no less. It forms a perfect straight corner, exactly like the corner of your computer screen or the edge of a piece of paper. Now, let's open that angle up even further. Say hello to the obtuse angle. This angle leans back. It's past that perfect 90-degree corner, but hasn't gone completely flat just yet. It's greater than 90 degrees, but strictly less than 180 degrees. Think of a reclining chair leaning back. Now, if we push that reclining chair all the way down until it's perfectly flat, we get the straight angle. This is an angle that is exactly 180 degrees, and as you might guess, it looks just like a perfectly straight line. But wait, what if we keep bending backwards, past that straight line? Well, then we enter the territory of the reflex angle. This angle bends way underneath. It's greater than 180 degrees, but less than 360 degrees. And finally, if we spin all the way around, like a skateboarder doing a full spin in the air, we complete a revolution. This is one complete turn, arriving exactly back where we started, making it perfectly equal to 360 degrees. Moving on to level 3, dynamic duos, angle pairs. Congratulations! You've totally mastered the single angles. Now let's look at what happens when they team up. We have 2 very important teams here. First, complementary angles. This is when 2 different angles add together to make exactly 90 degrees, a perfect right angle. On the flip side, we have supplementary angles. This is a linear pair, where 2 angles lock together to add up to exactly 180 degrees, forming a perfectly straight line. And here is honestly one of the most magical rules in geometry: vertical angles. When 2 straight lines cross each other like a giant X, they form vertical angles. These are the angles sitting directly opposite from each other. And the rule? They are always perfectly equal in measure. No exceptions. If the top angle is 50 degrees, the bottom angle is exactly 50 degrees. Next up, level 4, crossing the parallel universe. Okay, it's time to bring in the heavy machinery. Imagine 2 parallel lines. lines that will literally never, ever touch, sliced by a straight line called a transversal. Why does this matter? Well, interior designers and architects rely heavily on transversals. They use these exact math rules to arrange room partitions so that everything looks perfectly even and balanced to the human eye. Welcome to Level 5, the Z, F, and C rules. So how do we solve these massive parallel line puzzles without getting a major headache? I'm going to give you some secret letter cheat codes. Our first cheat code is the Z shape, which helps us find alternate angles. If you trace an invisible letter Z along the parallel lines and the transversal, look closely at the inside corners of that Z. Those angles alternate sides of the crossing line, and the rule is super simple. Alternate angles are always equal. Our next cheat code is the F shape for corresponding angles. If you draw a capital letter F right along your lines, look at the angles sitting under the arms of the F. They are in the exact same matching position on both parallel lines. The rule here, you guessed it, corresponding angles are always equal. And finally, we have the C shape for allied or co-interior angles. If you draw a C inside the parallel lines, you capture two interior angles on the very same side. But listen closely because this one is a trap. These angles are not equal. Instead, they are supplementary. They will always add up to exactly 180 degrees. Keep that in your back pocket. All right, Level 6, solving the geometry puzzle. Welcome to the boss battle. Let's put literally everything we've learned today to the test. Take a look at this algebraic setup. We have two expressions, 7x minus 15 and 2x plus 55. Step 1, look at their position. They're crossing each other like a big X. That means they're vertical angles. And what's our magical rule? They are equal. Step 2, let's use some algebra. We just set them equal to each other. 7x minus 15 equals 2x plus 55. Step 3, now we solve. We subtract 2x from both sides, add 15 to both sides, and boom, we get 5x equals 70. Divide by 5, and x equals 14. Boss defeated. And just like that, you've beaten all 6 levels. You are officially a master of angles. But hey, the game doesn't end when this explainer stops. I want to leave you with a challenge. Look closely at the room around you right now. Look at the windows, the floor tiles, the edge of your desk. Where do you see parallel lines, transversals, and hidden geometry puzzles waiting to be solved? Thanks so much for joining me on this adventure today. Keep learning, and I'll see you next time.
If you have learned something great today, please click in the subscribe button. Like, share to others. Thank you.